Now, I know most of us were here yesterday, and I assume most of those who were here yesterday heard my first two sessions, but I know also there's some folks here who were not here yesterday, and so you folks don't know me from a hole in the ground. So we should probably clear that up first. This is me, and this is a hole in the ground. So hopefully that'll be helpful. On a little more serious note, I didn't mention this yesterday, but I wanted to mention it today because I figured more people will be here today. Why I'm here anyway, at least talking on this subject, I am a former atheist. I was not raised in a believing home, and my heroes growing up were people like Isaac Asimov, Carl Sagan, and other atheists of the time. So secular humanism was my outlook on things. That's what we used to call atheism for you younger folks. And I was an atheist until well into my adult years. And I was an atheist and an evolutionist. I was an atheist because I was an evolutionist. I understood that science had disproven the Bible, that science showed how we got here without a creator, and so why would you want to believe in one anyway? Science tells us what the truth is. And it wasn't until I was working as an engineer in the U.S. military space program that I was confronted with evidence against my atheism and my evolutionism. And after spending the better part of a year trying to disprove that, I eventually was forced to admit that it is true, that creation is actually true, not an evolutionary account of origins. And now what am I going to do with that? So I struggled with that for a while and eventually became a Christian. And I like to mention this when I speak. I became a creationist first and then a Christian afterwards. I became a creationist because of scientific evidence. Now, two things with that. Number one, believing in creation is not sufficient to make one a Christian, because that's the work of the Holy Spirit, right? I mean, there are Muslims who believe in creation. So I'm not here teaching that we believe the Bible because we have creationary science to support it. That's not my message at all. The scientific evidence is on the side of creation, which is my topic. But the second part of why I'm mentioning this is because there are many in the creation evolution discussion, those on the other side of it, who say that Christians are creationists because we have to be, because the Bible says that God's the creator, he created everything, and so we are forced to affirm creation because of our faith in the Bible. And so our faith basically puts blinders on us, or so they say. That's blinding us from looking at the scientific evidence objectively. And if we could take off these blinders that our faith has put on us, then we would see all the evidence for the billions of years, neo-Darwinian processes in biology, and on and on and on. Well, I'm one of many for whom the opposite is true. I was convinced by the evidence first. And there's many other people in the creation movement like me, by the way, which is something else the other side doesn't like to mention. So that's why I'm here doing this. I love the subject, and this is especially important, I feel, for the younger people, of which there's many here in the audience. I think that's wonderful. You are growing up in a culture that increasingly is going to tell you you are a fool to believe that the Bible is true, and that science overwhelmingly shows that the Bible is wrong, as along with other religions and so on. So hopefully my time here at this conference will be profitable if it shows you the error of those claims. So as you can see, my title here for this talk is called The Goldilocks Cosmos. What does that kind of odd title mean? Well, I'm assuming people are familiar with the story of Goldilocks, how Mama Bear's bed was too soft and Papa Bear's bed was too hard, but Baby Bear's bed was just right. I think I have that correct. Maybe I got it mixed up, but anyway, our cosmos is in many ways just right. It's not too much this way, it's not too much that way, it's just right for us to be here. And this is true throughout the universe. In my time here today, we're going to start talking about the Earth. Does the Earth look like the outcome of random processes, or just physics operating over billions of years? Or does it look like the work of an intelligent designer who created it specifically for us to be living on it? What about our solar system? Is there evidence for design in it? Farther out still, we look at the Milky Way galaxy that our solar system is within. Is there arguments for intelligent design within our galaxy? And what about the biggest question, the universe itself? Does it look like the outcome of random processes, or does it look designed? Well, the Bible says, in the beginning, God created the heavens and the earth. And hopefully this is a familiar verse to us, but our culture says this is an illegitimate account of origins. We are not allowed to invoke this as a historical explanation. Why is that? Because it's a supernatural explanation. Now, the prefix super just means that which is above or beyond. So that which is supernatural is something that is above or beyond, outside of the natural. And we are told in our culture that only naturalism is an allowable way of looking at things. The idea that you can only evoke natural processes, things you can see in the world around us, to account for where we came from. And we're going to contrast those two views here in my time today. Now, of course, the Bible talks about the Lord having created the heavens for multiple reasons, for signs and seasons, to sustain life on earth, to declare his glory, and so on. My time today, I'm going to focus especially on this middle one. Even many secular scientists are admitting now that the earth, in particular, looks very well designed for us to be here. Now, they don't like the D word, because if there's design, that implies a designer, but they will admit that the earth is very unusual. This book here, written by two secular scientists down in Washington State, where I'm from, is called Rare Earth, saying how unusual the earth has to be in the cosmic scheme of things. How many things have to be just right in order for life to even be possible here. And then there's this other book called The Privileged Planet. Again, this is not coming from a creation perspective. Oh, and by the way, if you like my talk today, this book here, they made an excellent, excellent video from, which is on the back table, not my table, but the table next to mine. So if people are interested in that, that's available to you. So even many secular, or at least many non-creationist scientists are recognizing that the earth in particular looks very well designed for us to be here, and how do you deal with that? But even they don't go far enough, as you will see rather. In my time today, I'll be taking the secular view to its logical conclusion. Obviously, I hope it's obvious by now, I don't accept the billions of years, I don't accept the laws of physics explaining how we got here, and so on. But I am going to point out that if you do believe those things, take that view to its logical conclusion, and you will often wind up at a place where those people who do believe that worldview don't want to go. So secular scientists and atheists in particular are actually very inconsistent in their thinking. They're making all sorts of claims, but they are unwilling to accept the logical conclusion of what those claims will produce. So what does a secular scientist claim anyway for how this whole thing got here? Well, supposedly in the beginning, there was a vacuum with a quantum fluctuation that happened within that vacuum of space, and that was then the Big Bang. And my next session this afternoon is going to be going into the Big Bang in a lot more depth, talking about how this all supposedly happened and how it all supposedly accounted for us being here. But for my first session here, I'll just summarize the whole thing with this statement: nothing fluctuated and then made everything. And that's why we're here. So that's the Big Bang model in a nutshell. Again, I'll be spending more time on that here in my second session today. But supposedly the Big Bang happened, and then here we are almost 14 billion years later after the universe expanded and so on. Now, the Earth in particular came from a cloud of gas about 4.5 billion years ago. And I spent some time on this yesterday in my second session, so I'm not going to go through this again. But you will hear scientists talk about how the Earth is in the habitable zone, and how we're looking now for other planets around other stars and see if they're in the habitable zone. Well, what is the habitable zone? The habitable zone refers to the distance from the star, or in our case, the sun, within which, I should say the range of distances within which liquid water is possible. Because if a planet is too close to its star, or in our case the sun, then of course it'll be too hot and water can't remain liquid, it'll just be steam. Conversely, if you're too far away, the water will be frozen as ice. But there's a range in the middle, the Goldilocks zone, where it's just right for liquid water to be possible. So you will frequently hear scientists talk about, oh, well, we just discovered this other planet around some other star, and it appears to be within the habitable zone of that star, so maybe there's life there. Now, of course, there's lots of logical fallacies in that kind of statement. We spent some time yesterday in my first session talking about how impossible life is to form on its own in the first place. My point for now is just because a planet happens to be in the habitable zone, though, doesn't mean it's a great environment for life anyway. For example, here in our own solar system, there's another celestial body that's also within the habitable zone of our sun. And it turns out that's not a very hospitable place for life at all, is it? I mean, the moon's right next to the Earth in space, you know, orbiting around the Earth and so on. It's in the proper distance for all these wonderful things to supposedly become possible, but yet it is a very bleak, desolate place, isn't it? There's also the issue that water shouldn't have condensed out of that cloud of gas in the first place within our neighborhood in this cloud. I spent some time on that yesterday too, so I can not cover that again now. I spent some time yesterday, too, also talking about how the fact that the Earth, or how the Earth is uniquely designed for life. And this is something I am going to repeat from yesterday, because it's important for the folks who weren't here yesterday to hear about this. But there's a lot of things you can point out about the Earth that make it very unusual and make it look like it is indeed uniquely designed, there's that D word again, for life. For example, our Earth has a protective magnetosphere, a magnetic field around our planet that, among other things, protects us from harmful radiation from space, not only from our sun, but also cosmic rays from things farther out. Our rotation period's about 24 hours. We go around our axis, and 24 hours makes one day, right? And like I asked the question yesterday, who woke up in the morning thanking the Lord that the day is 24 hours long? Probably, well, maybe today some people did, having heard this yesterday. But again, 24 hours turns out to be a Goldilocks value. It's just right for a length of a day for us to have a moderate climate here on Earth. If we rotated much more quickly than 24 hours, well, then we start to have very high winds, possibly destructive winds on the Earth's surface. If we rotated a lot more slowly, then any spot on the Earth's surface would be exposed to solar radiation longer during the day, and then away from it longer at night, so you'd be a lot hotter during the day, a lot colder at night, much more violent temperature swings. But 24 hours is just right. And as I pointed out yesterday, 24 hours isn't some kind of foreordained conclusion. It's not a natural number for a planet to orbit at that, to rotate at that speed. Jupiter rotates on its axis every 10 hours. Its day is only 10 hours long. On the other opposite extreme, Venus takes 243 Earth days to rotate around its axis once. It also rotates backwards, by the way, but that's a different story. Backwards according to the secular model, anyhow. But our day, 24 hours long, is a Goldilocks value. It's just right for us. Our axial tilt, 23.5 degrees, gives us nice moderate seasons. Again, that's not some kind of natural number that a planet has to have. We see on one extreme, Mercury has basically no axial tilt at all. On the other hand, Uranus has over 90 degrees axial tilt. It's way over on its side relative to the sun. So planets with these types of things would have extreme seasons, but our Earth does not. We have a Goldilocks value there. Our orbit, nice and circular, which gives us roughly equivalent exposure to warmth from the sun during our year. Again, that's not a natural thing either necessarily. For example, Mercury's orbit is a lot more eccentric than Earth's, a lot more oval-shaped. So at some point in its orbit, it's much closer to the sun at perihelion than at other points in its orbit when it's much farther away. And it turns out when it's closest to the sun, it receives twice as much solar radiation as it does later in its year. So imagine if during 1 year's time, the amount of radiation we got from the sun went up by a factor of 2. It would double and then go back down, double and go back down. What would life be like here? Probably very difficult to sustain life. But again, the Earth's orbit is just right. Our atmosphere. The Earth's atmosphere is fairly thin, as you can see here. It's been compared to the skin of a peach. So if you imagine the thickness of the skin of a peach to the fruit itself, that's about how thick the Earth's atmosphere is compared to the Earth. And I think I mentioned this yesterday, space is actually quite close to us because the atmosphere isn't very thick. If you could drive at highway speed straight up, you'd be in space in about an hour. Space is very close to us, a very hostile environment very close to us. Yet we have a very pleasant place to live down here. Why is that? Because the atmosphere is thick enough to retain enough solar radiation and give us air to breathe and protect us from radiation from space and all these other wonderful benefits that it does. Yet at the same time, it's not too thick, because if it were much thicker, then we'd start to risk having a greenhouse effect on Earth like Venus has. Venus, often called Earth's sister planet because it's the same size, mass, and our next-door neighbor in space. Nevertheless, Venus is very different than Earth because of this greenhouse effect due to its thicker atmosphere. The atmospheric pressure on Venus, if you were down at the surface, is 92 times crushing pressure on the surface of Venus. And not because Venus has a lot more gravity, whatever, just because of this atmospheric effect. Its surface temperature is almost 900 degrees Fahrenheit. This has made it very challenging to actually visit Venus with spacecraft, by the way, because imagine trying to land a robotic spacecraft on a planet where the solder melts and drips out of your circuit boards. That's what Venus is like. But Earth doesn't have anything like that going on. Our atmosphere is this Goldilocks just right. Now, there's much, much more we could talk just about the Earth with these sorts of things. And you have to ask, does this look like the outcome of random processes? Just laws of physics working themselves out in a gas cloud? Or does it look like something that was actually designed for life? Now, as Christians, we are not surprised that the earth looks so well designed because the Bible says that it was. Isaiah 45, "Thus saith the Lord that created the heavens, God himself that formed the earth and made it. He hath established it and created it not in vain. He had a purpose, a plan. He formed it to be" what? Inhabited. So if an omniscient, omnipotent, benevolent creator made the earth as a wonderful place to live, then we shouldn't be surprised that that's exactly what it is. Yesterday, I also talked a little bit about our moon. I'm going to again repeat this material for the folks who weren't here yesterday. Our moon also has evidence of intelligent design in it. Now, that may raise a few eyebrows there, because who talks about the moon being intelligently designed? Well, there's multiple reasons to believe that it was. The moon is situated at such a way to raise tides of a certain level in Earth's oceans, and turns out that's a Goldilocks value in the amount of tides that it raises, because the tides actually help keep Earth's oceans circulating. So if the moon were farther away or smaller, then the tides it raises would be lower, and Earth's oceans would risk becoming stagnant, which would affect the entire food chain, including us, and be very bad. On the other hand, if the moon were larger or closer to us, then the tides would start to be destructive to Earth's coastlines. But it's not. It's just right. It's also just right to produce total solar eclipses for observers here on the Earth's surface. Despite the moon being 400 times smaller than the sun is, from our perspective, it's exactly the same size as the solar disk, because it's also 400 times closer to us than the sun is. It's also in an orbit that allows it to align in between the Earth and the sun, so that when all the conditions are right and everything all lines up, you can, for a couple of minutes, see a total solar eclipse, which is a mind-blowing experience, by the way. I pitched that a bit yesterday. I also mentioned yesterday that of 160-plus moons in the solar system that we found so far, this is the only one that is capable of producing these sorts of events for observers on the surface. So is that just an amazing coincidence, that the only place where such things are possible is the only place where there's observers to actually see them? Or is this reinforcement for the fact that the Lord made things for signs and for seasons? I think it's that latter explanation. The moon is also uniquely stabilizing. The moon's orbit around the Earth actually helps the Earth's rotation remain stable over long periods of time. As this author here wrote, Earth's obliquity would vary chaotically from 0 degrees to 85 degrees on a timescale of tens of millions of years, were it not for the presence of the moon. Earth's climatic stability is dependent to a large extent on the existence of the moon. Now, again, I don't believe the millions of years part, but the people who do accept the millions of years, I think it's interesting that the Lord created things in such a way that even coming from that standpoint, you have to grapple with challenges like this one, that over millions of years period, our axis would be doing this, 0 to 85 degrees over long times, if the moon weren't there to stabilize us. So indeed, the moon, too, does not look like the outcome of random processes. It, too, looks quite well designed to be the lesser light to rule the night, as the Bible says that it is. And of course, by quoting this verse, that also brings to mind the other light that the Lord made in that same verse, the greater light to rule the day, which, of course, is our sun. Now, who ever wondered if the sun was intelligently designed? Now we're getting into new stuff we didn't talk about yesterday. Here's a perspective that almost nobody talks about, right? But no, the sun is very well designed. First of all, life on Earth is completely and utterly dependent on the sun for multiple reasons. The sun obviously produces warmth for us on Earth. If the sun were to turn off tomorrow, then the only possible source of heat on Earth would be radioactive decay of material in the crust, which would be very little. So the Earth would quickly plummet to a temperature not far above that of space, and we would all die, as would everything else. The sun also ultimately provides all of our food, because sunlight is necessary for plants to grow, and plants are the basis in the food chain for everything else. Or conversely, in the oceans, plankton, the basis for everything else, also dependent on sunlight. So really, the sun feeds us. The sun also provides the oxygen that we breathe, because that's produced during plants' photosynthesis, right? Now, atheists think that all this is no big deal. As Carl Sagan, who was an atheist, once said, "Who are we? What are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy tucked away in some forgotten corner of a universe in which there are far more galaxies than people." Humdrum star. Our sun is no big deal, according to people like Dr. Sagan. Our star, the sun, is rather ordinary. In many respects, the sun is entirely a run-of-the-mill entity. Those of you who follow science and are interested in it, you've probably heard comments like this from people, right? The sun, just an average star, no big deal, right? Our sun, so important to us, is merely an ordinary garden variety star. Ordinary, humdrum, mediocre, move along, nothing to see here. But all this is totally not true. Our sun is completely not mediocre at all. Our sun is very unusual. First of all, our sun is brighter than 90% of all stars we see in the Milky Way. Well, already we're seeing something that's very unusual, right? It has more mass than 92% of the stars we see. In fact, if our sun were actually mediocre, it would be a red dwarf star, because red dwarfs are about 3/4 of all stars, so this is what an average star looks like. 3/4 of them are like this. And as you can probably gather by the name, red dwarfs are small and red. No big surprise there, right? So the redness tells us that they're actually a lot cooler than stars like our sun. And with the size and all the rest, red dwarfs put out anywhere from 5 to 10% of the amount of warmth and radiation that our sun does. So this is what a typical star looks like. And we should be very thankful we don't orbit around a typical star, because if we did, it would be one of those, and that would be very bad for us. Because red dwarfs are so small and cool, if you wanted to stay warm enough to have life on your planet, you have to orbit it very closely. So closely, in fact, that you would wind up in a tidal lock. A tidal lock occurs when one body is orbiting another body closely enough, it starts getting distorted from tides, and that actually locks it in the same orientation as it goes around. So for example, our moon, you may be familiar with the fact that the same side of the moon always faces the Earth, right? I mean, sometimes it's lit up and sometimes it's not, but it's always the same side facing us. We never see the far side. That's because the moon is tidally locked to the Earth. Well, if the Earth were orbiting around a red dwarf star, the same thing would be happening. The Earth would be tidally locked because it would be so close, so one side of the Earth would always be receiving radiation from the star, the other side would never receive any. And how possible would life be in that situation? Is the projector going dimmer or something? Did anybody else notice that?
Yeah, it did.
Is there anything we can do about that? I don't imagine there is, but I figured I'd ask. Red dwarf stars are also things you don't want to be orbiting in general, because they're very unstable and they flare frequently. They're sometimes called flare stars. Ah, there we go. See, I had the flare picture to bring it up. That's what it was. So as you can imagine, if you were orbiting closely around a star that is frequently erupting material into space, that's not a very healthy place to be, right? So again, if we were orbiting a typical star, that's what we would be orbiting. That's what a typical star looks like. But that's not what our sun looks like. And even among higher mass stars, so set aside the 3/4 that look like this. These are what the average ones look like. Even among the quarter that are higher mass than this, 80% of those are in binary or multiple star systems, where there's multiple stars rotating around their common center of mass. So again, if there's multiple stars orbiting each other, being in a planet around a system like that, and trying to have a stable climate where your orbit is varying chaotically, sometimes you're receiving radiation from one star, sometimes multiple stars, again, not a very good place for you to be. But we're not in that situation. Even among high mass stars, our sun is unusual because it's a class G star, which is down to about 7.5%, and even among solar type stars, the stars we see that are most like our sun in their size, their temperature, their mass, composition, and those sorts of things, the ones we see that are most like our sun is still unique among them. A little while back, a 30-year study of the sun's photosphere was concluded, where it was discovered that the sun is basically constant in temperature. Over that 30-year period, the sun's energy output varied by less than 0.1%. Now, we take that for granted, right? I mean, the sun goes up, the sun goes down, we go about our business. But this is very unusual. Stars don't act this way. Ours does, but the rest don't. Even among solar-type stars, for example, a study of these showed that even solar-type stars, the ones that are most like our sun, have super flares about once a century. What's a super flare? Well, you may be familiar with the fact that our sun has a lot of activity on its surface. So you have flares like this happen, and sometimes these can get pretty big. For example, this one here is larger perhaps than many. This one here you can see relative to the size of the Earth. So these can get pretty big. And you're probably familiar with the fact that when one of these happen, you'll hear about it in the news, and they'll say this, this radiation coming in might take out a communication satellite or do something like that. But as big as these are nothing compared to the super flares that I'm talking about. Take an average solar flare, the ones from our sun, multiply it by about 10 million times. That's a super flare. That's what solar-type stars frequently produce. What do I mean by frequently? Well, as this article here pointed out, sun-like stars normally produce a bright super flare about once a century. Think about how scarily frequently that is if you're trying to live on this planet. But this author said, why a super flare has not occurred on the sun in recorded history is unclear. Well, it's not unclear at all. The Lord created the sun to sustain life on Earth. So we shouldn't be surprised that that's exactly what it does. And again, our sun is unique in not behaving like this. And just for a little bit of perspective, we look in the sky and we see stars and we say, oh, there's nice little lights out there. Stars are very violent things. Here's a few admittedly extreme examples of what stars can do. This is V838 Mon. There's a star in the middle of this that is in the process of blowing up. This one here is actually blowing up in two directions at the same time. There actually is a star in the middle of that. So stars are very violent things. Our sun is not, though. That's because it's not the outcome of random processes. It's designed. As this author said, some of the popular perception of the sun is downright wrong. Writers sometimes tell us that it's just an average star. Not so. The vast majority of stars are smaller, cooler, dimmer, and less massive than the sun. As this author said, people say the sun is a typical star. That's not true. Almost all environments in the universe are terrible for life. It's only Garden of Eden places like Earth where it can exist. And I thought this is interesting because an author's writing about the Garden of Eden in the New York Times. So again, the question, does this look like the outcome of random processes, just the laws of physics working themselves out in clouds of gas? Or does it look actually designed? Our sun looks very well designed because it is indeed unique among all the stars that we see. Moreover, if you're going to believe in the billions of years and the random processes and all the rest of it, then you have an additional problem that you have to grapple with, and that's our understanding of stellar physics and solar physics and how this would all work. If the sun were actually 4.5 billion years old, then you run into something called the faint young sun paradox, which tells us that over the past few billions of years, the sun should have been getting slowly brighter and producing more heat. So if it's doing that all the time, then billions of years ago, millions of years ago, certainly, it would have been cooler and dimmer, right? Well, turns out that a few 100 million years ago, the sun would have been about 30% cooler, which would have made the Earth about 30 degrees colder on average, which meant the average temperature on Earth would be below the freezing point of water, and we would have an ice planet. Now, this is the time when the evolutionists want life to be forming in nice little warm ponds somewhere. And then life flourishes and the lush dinosaur environment and all the rest of it. That's not what the physics says would have happened. So if you want to believe in the billions of years, which again I don't, but I'm pointing out, take it to its logical conclusion, you have some real explaining you got to do in your model. Okay, so we've talked about the Earth, and then we looked a little further out and talked about the moon. Farther out still, we talked about the sun. Now let's look out on a larger scale. Is there evidence for us being in a Goldilocks kind of situation here? Well, yes, there is. If you're going to have life on a planet somewhere, where do you want that life to be? What environment could it have formed in? And again, I don't believe life formed without a creator, but there are those who try to claim that happened. So they have to try to explain how it could have happened, when most places in the cosmos it couldn't have occurred. For example, you can't have life forming in globular clusters, which are these spherical globular shaped clusters of stars, because these are called dead zones. The stars within these are metal poor, therefore you don't have the proper chemistry, the proper elements necessary to have life. Plus you have a lot of orbital perturbations. All the stars are so close that any planet orbiting a star is always going to be yanked one way or the other by gravitational forces. You're not going to have stable climates. So even the evolutionists have to say the chance of life having formed in one of these things is basically nil. Elliptical galaxies are also called dead zones. Their stars too are metal poor, and The stars tend to have more elliptical orbits, so you'd have varying climates with any planets within those. No, you need a spiral galaxy if you're going to have life. And it turns out our Milky Way is indeed a spiral galaxy. Imagine that. But being in a spiral galaxy also isn't enough to produce the conditions necessary for life. The center of a galaxy is also a dead zone because there's lots of nasty stuff in the center of galaxies. Lots of supernova explosions, lots of gamma ray bursts, neutron stars, black holes, a lot of other things in that environment that you don't want to be next to. So you can't have life in here, nor can you have life out on the edge either because stars, again, are metal poor out there, not with the necessary material for life to be there. No, if you're going to be in a galaxy, you have to be in a spiral galaxy, and you can't be just anywhere in the spiral galaxy. You have to be right about here. And guess where our sun is? Right about there. So even our position in the galaxy is optimal for life. And moreover, not just good for life, it's also perfect for observation. If we were within one of the arms of the galaxy, or especially in the center, then our nighttime sky would just be crowded with stars. It'd be very difficult to perceive things farther away. But being out here halfway roughly on the edge of this disk, we can look side to side and see, number one, inward toward our galaxy. Number one, outwards, we can see other stars as well. But we can also look upwards and downwards, if you understand my directions here. There's no directions in space. But we can look outside of our galaxy and thus perceive more of God's glory. So, multiple reasons for us to be in our location in the galaxy. Doesn't look random. I'm arguing design is the better explanation. There's many other things we could talk about too, arguments from design here. And as I said, there's been entire books written by secular authors talking about some of these things. So let's pretend for a minute to be one of these secular authors who wants to believe in the billions of years and wants to believe life formed by itself and everything got here without a creator. And here are some of the factors that they have discovered are necessary in their scenario to explain us being here. First of all, the planet that you want life to be on has to be within a solar system, but it has to be specifically configured in a certain way. You have to have Jupiter there for various reasons, but you can't have another Jupiter or Saturn compared to the ones in our solar system because that would disturb things too much. Those giant planets that you do have can't be in eccentric orbits because that would disturb the planet you're trying to have life on. Nor can you have hot Jupiters where the Jupiters are actually closer to the sun than ours is. But at the same time, you do need a Jupiter. So it has to be there. It can't be absent, but it can't be too close to you because that would disturb your planet's orbits. But at the same time, it can't be too far because then it wouldn't be protecting your planet from comets and all the rest of it. And here are just some of a few of the things that the secular authors have talked about being necessary for life to form somewhere. First of all, right distance from the star. You have to be in the habitable zone where you can have liquid water. You have to be far away from the star to avoid a tidal lock, but at the same time, you have to be close enough for complex life to be possible, but at the same time, far enough away for complex life to be possible. The star itself has to be the right mass so that it can have a long enough lifetime for life to develop there, not produce too much ultraviolet radiation, because that would kill life that was trying to form. You need stable orbits in the solar system. They have to be stable over long periods. The planet itself you're forming the life on has to have the right mass, enough mass to have an atmosphere and ocean retention, enough heat for plate tectonics, which they also think is necessary for life, solid molten core for other reasons. And I'm not going to go into detail. Obviously, I'm just giving you an overview of some of the things they're talking about. You need a big enough ocean. It can't be too little, but it also can't be too much. You don't want a water world because then you can't have life developing there on the land. The moon has to be the right size and the right distance. Its orbit has to stabilize the tilt of the planet it's on. The planet itself has to have the proper axial tilt so your seasons aren't too severe. Can I talk any faster? You have to avoid giant impacts because those, of course, would kill whatever life is trying to form on that planet. You need enough carbon for life, but not too much because then you get a runaway greenhouse effect. Your atmosphere has to have various properties. Oxygen has to evolve, so photosynthesis is possible, but you can't have too much oxygen because that would be bad, but you can't have too little because then there'd be nothing to breathe. It has to all evolve at the right time, and there's a lot of other factors here too, which I don't even have time to explain. On and on and on it goes. And this is quoting from secular work. These aren't creationists we're talking about. Indeed, our cosmos looks just right for us to be here. So what are the implications of that? But it goes on even beyond everything being just right. Everything is actually more than just right. Everything is really finely tuned. And now we're getting into some subjects that make some secular people very uncomfortable and don't like to talk about. How do you deal with a cosmos that looks so well designed for us to be here? Well, the obvious explanation is that the cosmos is designed, right? But being designed implies a designer, and since that's off the table, we have to think of some other explanation. Well, one possible explanation is called survivor bias. Survivor bias is the idea that whatever situation you're in, you shouldn't be surprised, because if it were impossible for you to be in that situation, you wouldn't be there to observe it. In other words, if life has a lot of specific requirements to be possible, then the fact that we're here shouldn't surprise us that we see those requirements fulfilled. Because if the requirements hadn't been fulfilled, then we wouldn't be here to see them. Now, is this good logic? Well, it requires, first of all, a lot of other solar systems to be possible. You need a lot of different solar systems so that with a large enough number, one of them will just happen to have the proper combination of characteristics for life to be possible, right? But second of all, logically, it doesn't even hold up anyway. As Thomas Nagel pointed out, now he's an atheist philosopher, he said, one doesn't show, I apologize for those of you in the back who can't read the print here, I'll read it to you. One doesn't show that something doesn't require explanation by pointing out that it's a condition of one's existence. If I ask for an explanation of the fact that the air pressure in the transcontinental jet is close to that of sea level, it's no answer to point out that if it weren't, I'd be dead. You get the logic here. If you wake up on an airplane and say, well, how did I get here? There was obviously some plan for me to be on here. This thing was intelligently built to sustain me as I travel. Well, and then someone else says, well, no, that's not the proper explanation. The proper explanation is, if you weren't in the plane, you'd be dead. That's got nothing to do with it, right? That's the kind of logic the evolutionists are trying to invoke, though, with a survivor bias. Moreover, survivor bias breaks down when you point out that the entire universe looks well designed. So if the entire universe is designed, then you can't start invoking other solar systems because that's irrelevant. You got to explain how the universe itself looks designed. What do I mean when I say that? Well, the universe itself, both on the largest scales and the smallest scales, looks extremely finely tuned, even down to the laws of physics and things going on in chemistry. Here's an example. This is from Sir Fred Hoyle, who was no friend of creationism by any stretch of the imagination. He said he was investigating the properties of the carbon atom and was blown away by how the carbon atom works. He said some supercalculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule. A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. So even within the constants of physics and chemistry, things are so finely tuned that people like Sir Fred Hoyle are scratching their heads saying, what's going on here? This is another author, and who this author is might surprise you. He wrote, a change of as little as 0.5% in the strength of the strong nuclear force, or 4% in the electric force, would destroy either nearly all carbon or all oxygen in every star, and hence the possibility of life as we know it. Change those rules of our universe just a bit, and the conditions for our existence disappear. Most of the fundamental constants appearing in our theories appear fine-tuned. If they were altered by only modest amounts, the universe would be qualitatively different, and in many cases unsuitable for the development of life. For example, if protons were 0.2% heavier, they would decay into neutrons, destabilizing atoms. And if the protons in your body started destabilizing, that would be a bad thing, by the way. Our universe and its laws appear to have a design that both is tailor-made to support us, and if we are to exist, leaves little room for alteration. That is not easily explained. It raises the natural question of why it is that way. Who wrote this? Stephen Hawking, militant atheist, apparently to his death, which is tragic. So the entire universe has extreme fine-tuning, built into the laws of physics themselves. Even on a larger scale, though, if you start dealing with the Big Bang model, you have additional problems yet. For example, a few years ago, some scientists were calculating how finely tuned the Big Bang had to be in order to explain a Big Bang problem called the flatness problem, which I'll talk a little bit about in my next session. But they discovered that to explain a certain issue within the Big Bang model, the Big Bang had to be finely tuned to 1 out of 10 to the 60th power. That's a 1 with 60 zeros out of it. Specifically, the amount of matter in the early universe had to be finely tuned to that amount. So here's an analogy. If you're walking on a tightrope across a canyon, and the canyon is a couple thousand feet deep, and there's a fast-flowing river down at the bottom of the canyon. Now, if you walk the tightrope successfully, you make it to the other side. If you take one slip, though, one false step, you don't wind up one false step worth away from where you were. You wind up thousands of feet from where you were. Now, if you hit the river, you wind up miles down that way. If you miss the river and hit the river bank, then you're thousands of feet down that way. But either whatever your fate is, you don't wind up merely one step away from where you left, okay? So in a sense, your tightrope is finely tuned with drastic consequences in either direction. The Big Bang works the same way. They found out that if there was a little bit less matter in the early Big Bang than what the universe has today, then there would be runaway expansion early in the universe's history. Galaxies couldn't have formed, stars couldn't have formed, planets couldn't have formed. We wouldn't be here to look at it. On the other hand, if there was 1 out of 10 to the 60th power more matter than what the universe currently has, then there would have been runaway gravitational contraction and collapse. Everything would have collapsed into black holes, no galaxies, no planets, no life. So the Big Bang, extremely sensitive to this little window of matter to explain us being here. Now, this is a big number. How do we understand big numbers? Well, here's an analogy. There's about 10 to the 80th power atoms in the universe today. Now, if the Big Bang had to be finely tuned to 10 to the 60th, then you can divide one by the other, and the precision, the window, the margin of error for the Big Bang is about 10 to the 20th atoms. That's about the amount of matter in a single grain of sand. In other words, the Big Bang supposedly made all the matter that turned into our universe today. If it had made 1 grain of sand less than what's currently in the universe anywhere, we wouldn't be here to see it. If it had made 1 grain of sand's worth of stuff more than what's currently in the universe, we wouldn't be here to see it. Does this sound like a random event to you? Think about how big the universe is, all the stars, all the galaxies. 1 grain of sand, that's your margin for error for us to be here, according to their model. Then the problem got worse. Now the fine-tuning is up to 10 to the 123rd power for the Big Bang model. That's 1 out of this number. As this author says, our universe appears surprisingly fine-tuned for life in the sense that if you tweaked many of our constants of nature by just a tiny amount, life as we know it would be impossible. Some of the fine-tuning appears extreme enough to be quite embarrassing. For example, we need to tune the dark energy to about 123 decimal places to make habitable galaxies. So again, back to our analogy, 10 to the 80th power atoms. Now the Big Bang has to be finely tuned to the 10 to the 123rd. So now your precision is 10 to the minus 43 of an atom. And if you don't know scientific notation, that's this fraction. So now we're down to fine-tuning less than a grain of sand, less than an atom within a grain of sand. It's this fraction of the mass energy of a single atom. That's how finely tuned this random Big Bang that happened without a creator and a designer had to be for us to be here talking about it. As this very secular physicist said, this discovery was a cataclysm for physicists like him. And the only way that we know how to make sense of it is through the reviled and despised anthropic principle, which is the idea that the universe somehow had to be made to accommodate human life. And you can tell what he thinks about that idea because of the adjectives he uses. Why is he so disgusted with this idea? Because it implies a creator, doesn't it? So we saw they reject the idea that the cosmos is designed. We saw that survivor bias doesn't make any sense either because the entire universe is well designed, finely tuned. So their only way out of this trap, other than acknowledging their creator, is to say there's a multiverse. That's the solution to the problem. You see, as crazily finely tuned as our universe is, yes, it looks very embarrassing for us that our randomly produced universe is so amazingly finely tuned. But it's not a problem, because there's actually an infinite number of universes that exist. And with an infinite number of universes, every possible combination of characteristics will be out there somewhere. So we just happen to live in the one that looks so amazingly finely tuned, but there's no designer. The idea of infinite universes is now being called the multiverse, for multiple universes. And the Big Bang has actually been acknowledged now to produce a multiverse for various reasons that I won't bother going into. But secular cosmologists now believe, for the most part, that there's an infinite bubble, or infinite number of bubble universes always bubbling out of cosmic inflation, always producing new universes. It's been doing it forever, or eternally long, it'll continue doing it forever, and so on. Now, I should take a moment and mention, you might be wondering, how could there be more than one universe if the universe means all that there is? Well, they've redefined the term now. Universe now just means all that part of physical reality that we could ever perceive, that we could ever observe, even with the best possible telescopes and so on. So regardless of how good our technology ever is, that theoretically maximum visible amount of reality, that's our universe. But they're now asserting there's all these other universes out there. So you see how this allows them, they think, to escape from the fine-tuning trap, right? So they'll admit, yes, our universe is crazily finely tuned, but there's an infinite number of universes out there. So in an infinite number, every combination will be out there somewhere, so we just happen to live in one of those finely tuned ones. But think of the implications of this. What I just described to you is how far they usually go. Now let's take it further to the logical conclusion that they don't want to talk about. Among other things, this means there's infinite copies of you out there in the cosmos, in the multiverse. Because think about it, in a finite volume of space, let's picture a sphere the size of our that our solar system would fit within. In a finite volume, there's only a finite number of possible combinations of particles within it, right? It's a very large number, but there's still a limited number of ways you can arrange matter inside of a volume. But if there's an infinite number of universes, then there's an infinite number of these volumes of space out there. So any conceivable arrangement of matter will be out there an infinite number of times. You're still with me? This means there's an infinite, in the multiverse, there's an infinite number of universes where we're all in the same room having the same talk. And you're sitting in your same chair with the same memories. You are you. As this article here points out, is there another copy of you reading this article, deciding to put it aside without finishing this sentence while you are reading on? A person living on a planet called Earth with misty mountains, fertile fields, and sprawling cities in a solar system with 8 other planets. The life of this person has been identical to yours in every respect. This is you, an infinite number of times out there. You probably find this idea strange and implausible. Yet it looks like we'll just have to live with it, since the simplest and most popular cosmological model today predicts that this person actually exists in a galaxy a long ways from here. If space is infinite and the distribution of matter is sufficiently uniform, then even the most unlikely events must take place somewhere. Remember this phrase, we're going to come back to this. In particular, there are infinitely many other inhabited planets, including not just one, but infinitely many, with people with the same appearance, name, and memories as you. Indeed, there are infinitely many other regions of the size of our observable universe where every possible cosmic history is played out. So there's an infinite number of universes out there where we're having the same exact talk right now. There's an infinite number where we're having the same talk right now, but you had something different for breakfast this morning. There's an infinite number where this talk happened yesterday. There's an infinite number where it'll happen tomorrow. On and on it goes. There's an infinite number where the American South won the Civil War. There's an infinite number where there never was a Civil War because the 13 colonies lost the revolution against King George III. And on it goes. Every possible combination you can think of is out there an infinite number of times, because even the most unlikely events must take place somewhere. And the multiverse is big business now. This is just the books I could fit on one slide talking about all these universes that nobody can actually ever see. As this author said, our most successful theories lead to the inescapable conclusion that our universe is just a speck in a vast sea of universes. The multiverse is not some kind of optional thing, like can you supersize or not, says this physicist. Our own history, he says, tells us it's there and we need to deal with it. So regardless of how strange it might sound to you, you need to just deal with it, because this is science, baby. But is it really? What's the one thing we know for sure about all these other alleged universes? They're all unobservable by definition. We can never observe them, even with the hypothetically best technology and all the rest of it. So they're unobservable. They're outside of the natural world that we can observe. What word did we use to describe things that are outside of the natural? Supernatural, right? Didn't we talk about this earlier, though? We're not allowed to use supernatural explanations, I thought. Or should I say, we aren't allowed to use supernatural explanations. They can, apparently. And even some secular thinkers are unhappy with this hypocrisy. This author said, these multiverse theories all share the same fundamental defect. They can be neither confirmed nor falsified. Hence, they don't deserve to be called scientific. Multiverse theories aren't theories. They're science fictions, theologies, works of the imagination unconstrained by evidence. My own moral concerns about the multiverse have more to do with worry that pseudoscience is being heavily promoted to the public. If a wrong idea is promoted for enough years, it gets into the textbooks. We've never seen that happen, have we? It becomes part of the conventional wisdom about how the world works. This process is now well underway with multiverse pseudoscience. Multiverse is not just pseudoscience. Ultimately, it is absurd. Let's talk about that now. Bible says, ye shall know them by their fruits. Now, multiverse is now an integral part of Big Bang cosmology, because Big Bang cosmology requires inflation, and inflation would produce a multiverse, and the multiverse is necessary to explain fine-tuning anyway. So if this was all a good scientific model, then it would produce good scientific fruits, wouldn't it? But if it's a bad scientific model, then it's going to produce bad fruit. So let's examine the fruits of this way of thinking and ask the question, is this really science? Or is it just, ultimately, science fiction? For example, what's in the multiverse anyway? As this author said, there are infinitely many other regions the size of our observable universe where every possible cosmic history is played out. Well, let's see. What would that mean? That would mean Captain Kirk and Mr. Spock are real people. Right? They're out there an infinite number of times. Even the episodes that are really painful to watch are true if the multiverse is true. Because even the most unlikely events must take place somewhere. Other authors are using this thinking to try to get rid of a beginning, because that implies a creator. As this article said, our universe may be the offspring of some other universe. Baby universes fluctuate into existence in both directions of time, eventually emptying out and giving birth to babies of their own. So universes are having babies, which are having more babies forever and ever, on and on it goes. But in his multiverse, in order to escape some specific problems, each of his baby universes would experience an error of time, but half would have an error that was reversed with respect to that and the others. So in his proposal, there's all these baby universes always being born, but in half of them, time flows backwards. Now, is that science, or is that just science fiction? Another author came up with an interesting implication of this. Now, he wasn't writing about the multiverse specifically, but the logic still holds. He said, as we go out exploring the rest of the universe, we need to be careful, because we're going to run into, life evolved here by itself, so it presumably evolved other places too. So we need to be careful, because we might run into some stuff we don't like. I think our projector's going, is this getting dimmer again? Yeah. Okay, there we go. See, I had to complain about it. So he said such life forms that we run into, could well be advanced versions of dinosaurs. Now, his logic is that on Earth, dinosaurs got wiped out by a freak asteroid collision. But elsewhere out there, that wouldn't necessarily be true. So the dinosaurs would have continued evolving. They'd be advanced dinosaurs, and we would be better off not meeting them. And that's true, because there's nothing worse than running into a dinosaur that has better weapons than you do. Right? But wait, if the multiverse is real, that's real. There are dinosaurs driving tanks right now. Right? Even the most unlikely events must take place somewhere. So, obviously, though, is this science, or is this just science fiction? We need audio. Too late. I didn't know you turned it off. Spoiling my joke here. But if the multiverse is true, that's a documentary. Isn't it? Moreover, maybe the fact that our universe is so finely tuned can be explained by the multiverse. As this author said, in all seriousness, it is proposed that our universe was created by life of superior intelligence existing in another physical universe. Intelligent beings might possess not only the knowledge to design, but also the technology to build universes. Well, if the multiverse is true, it's been going on forever. There's an infinite number of universes out there with presumably countless numbers of alien civilizations, many of which have been out there for a long time. Maybe they've evolved enough to be able to create other universes. This explains why the constants of physics have their observed, finely tuned values. It might even help us to understand why our universe is comprehensible to the human mind. So that's why the universe looks designed, not because God did it, but because aliens did it. But is this science? Or is it just... I guess we'll just skip the audio then if you got to do this. Here's another author. Again, these people are serious about this. It's a perfectly acceptable supposition that the world as we know it is a vast computer program run on machines built by an intelligence we know nothing about in a different universe that may be like one of the ones we speculate about, or maybe an alien one. If you accept the multiverse idea, it is almost inevitable that there are computer-based universes out there. Because if aliens evolved in the multiverse, then presumably they'd eventually get good enough technology to be able to simulate universes, right? Somewhere among the universes, there would, in all probability, be universes where civilizations had developed far enough to produce a matrix-style universe. Chances are we do live in a computer simulation of a universe. Think about this. We can make computer simulations in our civilization, right? How many simulations has mankind run so far? I mean, thousands, millions, some large number, right? So far, just in our limited experience, there's countless simulations per one real physical simulation. If aliens can simulate universes, eventually the simulated ones will mathematically way outnumber the real ones. Therefore, mathematically, according to the multiverse idea, even though it seems that we live in a real cosmos with real planets and real stars and real galaxies, that's actually an illusion because we're part of a video game being played by some alien somewhere. That's what the math says. Now, you might think this is silly. There are scientists seriously researching how to figure out if we live in a numerical simulation. Normally, at this point in the talk, I point out to people, tax dollars paid for this. But here I can't say your tax dollars because it's my tax dollars, not Canadians. But yes, people are quite seriously looking into this. But wait, let's think about the implications of this, though. If aliens could eventually evolve to have such good technology to make simulations of universes, they can also simulate universes that contain aliens that are simulating universes, right? As this author said, in all seriousness, there could even be multiple levels of simulation. The computer our universe runs on could be itself a simulation on another computer. So it's not merely that we're living inside of a video game being played by some aliens. Those aliens are part of a video game being played by other aliens. But then why stop there? Maybe those aliens are part of a video game being played by some aliens that are part of a video game being played by some aliens that are part of, well, you get the idea, right? Now, is any of this science? No, obviously not. But this is the logical conclusion of multiverse theory, isn't it? The fruits of multiverse theory are ultimately absurdity. Why, then, is this going on? Cosmologists and astronomers, very intelligent men and women. Why do they believe this stuff? Why do they promote this stuff? Here's why. If there's only one universe, you might have to have a fine-tuner. If you don't want God, you'd better have a multiverse. The Bible says, the fool hath said in his heart that there is no God. So, now don't get me wrong, I'm not calling these people stupid. Again, they're very intelligent men and women. But they are promoting a model that is absurd in the philosophical sense. That's because, as the psalmist said, the fear of the Lord is the beginning of wisdom. Now, if you're trying to make a model that denies God's creation as its fundamental assumption, there is no God, the universe must have got here by itself somehow, let's figure out how that happened, then you're denying the fear of the Lord at the foundation of your thinking. You're denying wisdom as the foundation of your thinking. And when you deny wisdom, whatever it is you wind up believing has to be foolishness. When you deny the truth, then whatever it is you wind up believing has to be a lie, doesn't it? And that's where cosmology is today, at least secular cosmology. So we can see then this is not a battle of religion versus science. It's not that they have the science and the facts and we have the religion and blind faith in a book. No, science is on our side because our cosmos looks designed, because it is designed. It's not the product of random processes. Because the heavens do not declare that a Big Bang happened, the heavens declare the glory of God in many more ways than we can possibly even understand. So, as I mentioned yesterday, I have an email newsletter available on my website for those of you who like this rather unusual perspective on things.